temperature decreases, and according to Wien's displacement law, lambda t equal to constant. So as the temperature decreases, T decreases. Now what do you expect now, lambda? Lambda should increase. So the wavelength emitted by that particular object, what will happen, cooling object will keep on increase with the time. And that's what the variation is showing here. So don't say source of light. Huh? I don't think so. We have any source of light where I can change lambda and that easily. Agree? Tube light. Can you change wavelength of tube light? Not possible, no? You should have more generalized approach here. Okay, let's get into the question now like this. Huh? There's a basic idea. Cooling object, so with the time the temperature decreases. So Stephen's law, and we know P equal to E, also like a Newton's laws of cooling, better apply that, and the temperature will decrease, no? If you plot the temperature versus time, exponentially decreases, if you can. So the lambda should increase. Here is telling some, it cools in such a way that the lambda increases linearly. So I'll take it out this graph, because it decreases, temperature decreases exponential. Put that one here. So may not that linear variation what we don't get, no? Now get into the problem. Read the question now. Now, so definitely you can expect a question, thermal radiation, photoelectric effect. This particular body will be kept nearby the emitter. Then as it's gives out radiation, that radiation will fall. What is this, sir? But you said light is incident, because what we took, light incident on on emitter. But this is a radiation. This radiation is also nothing but light, no? Light, or a good example, candle. So what is giving? Thermal radiation or is emitting light? Both, no? In radiation chapter, we called it thermal radiation. Now you can call it as a light. Candle. So the radiation, what all we get, thermal radiation, or you can call light energy. This light energy falls on phototube, photoelectric effect cell. We can discuss the concepts here. Getting to the question, read once, some lot of information he has given. So that 2 minutes, the signal is switched on off for intervals of 2 minutes. So let's plot the graph, so that from graphs we'll see what information we'll get it here. No, 2000, 3000, 2 minutes, how much it will become? 120 seconds, no? Then maximum will be 7800. Yeah. Then it will be off for certain time. Then again, it will begin like this. Yeah. So again, it will continue. This one. This will be 3000 lambda in Armstrongs, and this should be 7800. Check it once. This is 120 minutes, 120 seconds I'm writing. This will be 180. this will be 300. And if you add this 60, no, so this will be 360. Again, it will continue further. Yeah. So this was the lambda varying with the time in this way. There's a t is in seconds. And incident on a metal sheet of work function 2 electron volt. Shall we calculate cutoff wavelength? Cutoff wavelength, I think we need cutoff wavelength. Just wait, I'll push this up. Now come for this. Cutoff wavelength, how to get the cutoff wavelength? We know work function. From work function, we'll get the cutoff wavelength. SC by lambda naught should be equal to work function. We know work function, we'll get the cutoff wavelength. Anybody? Cutoff wavelength?
6200 electron, 6200 angstroms.
3200 or 6200? 12375. Okay, this one.
Sir, 6200 angstroms.
6200 Armstrongs. Huh? Okay, we got this one. If energy of photon is greater than 2 electron volt, then it will get ejected, no? Am I right? I think so we'll come to later on this lambda varying. First of all, we'll analyze here. Work function is 2 electron. Any photon whose energy is greater than 2 electron volt, what will happen? It will get, that particular photon will generate a photoelectron. Each time the signal is again started, so this is what he has put a condition. Find the maximum photocurrent. The photoemission efficiency is telling. So he's asking to get that maximum photocurrent. How to reach all these things, where the lambda is variable, that too there's a big problem. So cutoff wavelength 6200, no, the 6200 mark, we'll put that mark here. Yeah, I think, okay, fine. So this is the 6200. So when the wavelength of photon becomes incident, when the wavelength of incident radiation becomes greater than 6200, no photoelectric effect. Will I agree? Shall I use word no photoelectric effect? And when there'll be photoelectric effect? When the wavelength is less than that. And what is the permitted wavelength? 3000. So where the photoelectric effect will occur? The photoelectric effect will occur only in this region. I'm putting, so where there's a photoelectric effect and where there's a no photoelectric effect. So the photoelectric effect occurs here, no? PEF. Or PF will be photoelectric effect occurs. So from year to year, again, no photoelectric effect. Again, there will be photoelectric effect. Again, no photoelectric effect. Able to understand? So once the wavelength of the incident light becomes more than 6200, then the energy of photon will become less than 2 electron volt and there won't be photoelectric effect in this region. So can we calculate that time? This particular time is needed at which it will stop. how to bring that time. I think directly here, the lambda should be what? 6,200 you substitute here. I'll get
80
into the method.
seconds.
80 seconds. Okay, fine. Yeah. So 3000 plus 14 to t. So when this becomes equal to threshold wavelength, the time interval will call t naught. So this should be equal to 6,000 80 seconds. So this is what I'll write 80. It's a calculated, not given. We have to calculate. So t equal to 0 to 80 seconds, there'll be photoelectric effect. From 80 to 120, no photoelectric effect. Though light is incident, radiation is incident. Then what about next 120 to 80? It is switched off. The source itself is switched off. Are you able to see? Off, on. Able to understand the question so far? If once you understand, it's very easy. Nothing is there. You see that one. No integration, nothing. What is our entire question? So somehow what happened? We are able to tell that first 80 seconds it will be there. Next from 80 to 180, though radiation is in, though photons are incident, but from 80 to 120, no photoelectric effect occurs. And anyway, that one. Here 120 to 80 is switched off. No, I should not write no PEF. I'll write here. Here only no PEF, huh? Because when source is off, no question of any PEF. No, it will give another meaning. This 80, this should be 880, 260. So this what happens here. Okay, now we got almost all the information. Let's see next again. Finally, the metal plate is grounded so that it always remains neutral and electron clouding is negligible. Find the maximum photocurrent. So what is the meaning of this? So it's telling this is the metal plate. I'll try to explain this one. So there's a radiation incident. Lambda of t. So this is having a work function and it is grounded. And here I'll connect one emitter which will read this particular thing. So first what will happen? The electrons will be ejected, no? And what all the positive charge it will acquire? The electrons from the earth will flow and will keep that as neutral and no clouding. In fact, zero kinetic energy electrons also will be ejected, but it is asking no clouding. So neglect that. Electron clouding is telling. Practically will occur, we are neglecting that. Photocurrent is asking, maximum photocurrent. How to bring maximum photocurrent?
Wavelength is equal to threshold wavelength.
Yeah, this one, no? Yeah. First, number of photons received for what interval of time? So how to calculate number of photons received here? When number of photons incident are maximum. So when number of photons incident will be maximum. So we'll go back to the basic our definitions. Huh? Number of photons emitted by the source. Let's bit I'm taking help of this. Power of source by hc by lambda, no? Energy of photon. Number of photons received by the source, number of photons received per second, or the number of photons incident on the plate per second. So this is what I'll write ns. We know power of source given 100 watt. What to do with EP? 2 electron volt only. 100 by 2 into 1.6 into 10 to the power of minus 90. Then all these photons are incident. So how many, what is the efficiency? Now we'll go for efficiency, that one. So what is telling the efficiency? Where is it? The photon emission efficiency is 0.01%. So shall we put it this number of photo electrons will be 0.01 by 100 into ns. So can we calculate now photo electron? So all this will be per second, no? This is. So these many electrons will correspond for that particular current that will flow through this wire. Then you get the maximum current. I think this is nothing but all their per second, no? So it will become nothing but current only, what you call NE. Current will be equal to NE, maximum current. Why I wrote EP, this from where? This should be HC lambda, and lambda is varying. How to justify this? SC by lambda, no? So how to justify this? So why you wrote that 2 into 2 electron volt only? Why not any other thing? What is the work function of the metal? 2 electron volt. So if the energy of photon is greater than 2 electron volt, then only possible, no? There's the least energy. If the energy is least, then the emitted number of photons emitted will be maximum. Will agree? So what is the least energetic photon in the this particular radiation? 2 electron volt. So least energetic photon, what happened? Corresponding to that, there'll be maximum number of selected photons will be generated here. So like this I'm putting, but this is totally against the basic definition. No? Can you agree? Because what I said, number of photons depends on what? Only on intensity. But here what happened? We are bringing the idea of the wavelength. Will I agree this? What all I initially I made all the basic things against that one. So this is the thing what happened now in the modern physics. Earlier, if you say 30, 40 years back, the technology was not sufficient where we can capture that radiation, everything. So now what happened, even we are able to produce a light source where the lambda will vary, practically possible to certain limitation. That one. So these are some problems which I'm bringing, where the number of photons emitted by the source per second can be controlled by varying the wavelength. But as such, the traditional devices what we have, how to vary number of photons incident on this particular thing is by moving the source nearby it. Even the power of source I cannot control. That's what the basic definition of photoelectric effect chapter says. The books, what the books are, the theoretical ideas. It was the fundamental thing related to the photoelectric experiment. But now modern devices have come. So like this, some experimental setup has came up. But still stick on to the basic things only. This is only numerical. So don't again get carried away by varying wavelength, we can control the number of photons emitted by the source. Provided open, you should know how to vary the wavelength of source. So that source will be different. So what are they? If you say, whenever they say source, you should assume that wavelength is fixed here. If you mention wavelength varying only, then you should bring this idea. I'm just picked up this problem to reflect that idea here. So such a things will they ask in advance? I'm not sure, because these are the numericals. Only it's a numerical, but we don't have anywhere theoretical discussion on this. No book has put forward till date that by varying frequency or by varying wavelength, number of photons can be increased. So maybe there's a modern, with the help of the modern technology, we are able to produce the source, like a light source whose wavelength can be varied. So based on that, they made problem, or they may say hypothetical, in a hypothetical situation, as you can assume. But what all you carry on the concepts, everything, you should see that As you vary intensity, number of photons will change. So why I took this one? Because there's the least energetic photon corresponding to that, the number of photons incident will be maximum. Fine. This is, I think the answer will come 5 milliampere. Check it. Okay, I'll start. This was the photel